Well then, plenty of stuff to talk about today, including a coronal mass ejection impact that's occurring as we create the video. The Earth-facing portion of the solar disk dominated by massive plasma filaments. We'll be talking about that and lots more. So strap on your safety belts and put on your sunglasses. We'll be staring at the sun here at the Smash News Network, Least Busted Damon News. Congratulations on realizing that the channel exists. This is a 24-hour video featuring ionized helium and iron. And you see a bunch of dark features up here. A lot of those are filaments. There are also coronal holes visible, like this one right here. So plenty of features to cover. Here's a full disk view. And yeah, it's indeed lots and lots of solar filaments. If you want to name them after living people, make sure you follow us over on Twitter. And use the hashtag #NameThatFilament to name your favorite filament after living people. We've got the Jerry Seinfeld, Larry David, and Bill Burr filaments still remain intact up here. Three of America's favorite stooges, right up there in the northeastern limb. Here's the equatorial region. We've got massive setting sunspots in the northwest and a magnetically capable group in the northeast. Southern hemisphere a little bit less active. Here's a view of that anyway, as we provide holistic information about the closest star, El Sol, Helios, the local yellow dwarf. And let's take a look at what's going on in terms of sunspots. So no major changes here. These groups that are setting in the northwestern limb are extremely likely to produce large flares. The possibility of X-class flares indeed is there. So don't be surprised to see a large solar flare of M or X-class variety coming from that group. It could be happening as we make the video. You never know. It's been known to occur. Besides that, these groups are mostly stable here. This one grew a little bit, as you can see. Anyway, here's your colorized magnetogram. This is yesterday plus today, so May 11th plus May 12th to date. Continuing on here, let's see what's erupting on Crescent Earth. As we're always interested in volcanic eruptions, I mean, there are some situations where volcanic eruptions are space weather, such as on Jupiter's moon Io. We know that the volcanic activity on Io does interact with Jupiter's ionosphere. Anyway, Sakurajima is currently erupting and producing a 7,000-foot plume of volcanic ash. Please do not pole vault the caldera. If you're going on a volcanic vacation, leave your vault pole at home. Krakatau, daughter of Krakatoa, remains on the list here. Looks like a flight level 070, 7,000-foot ash plume over the Sunda Strait. Semeru in Indonesia, exploding, flight level 140. That's a 14,000-foot ash plume. Nearly 3 miles high there over Semeru. Popocatépetl exploding, flight level 230. It's a 23,000-foot cone of volcanic ash there over central Mexico, and not sure about Sabancaya, although continuous emissions are occurring in Peru. As far as earthquakes go, there were 2 interesting large quakes in California. Yeah, California. That's a 90-day bar graph there behind my head. And there is the largest U.S. quake over the past 24 hours. That is known as the Lake Almanor quake. And yeah, there you go. There's the location of that. That was, by the way, a 5.5 magnitude quake there. Anyway, let's see what else has been going on in the past 24 hours. Largest quake of the past 24 was a 5.9 near Japan. And we'll scroll up the list here, citing quakes over a 5 magnitude. Looks like some decent quakes in Hawaii there. Although not of a 5 magnitude, so we'll leave that alone. The 5.5 at Lake Almanor occurred at 23:19 Universal Time yesterday evening. That's a decent-sized quake, the largest in the U.S. for quite some time. Of course, many aftershocks there, including a 5.4 also. Besides those quakes, not too many events over a 5 magnitude. There was a 5.4 near Guam. That was at 8:02 this morning, and pardon the lateness of this video. I was up at 4 a.m. last night and went back to bed after filming some aurora. There's a 5.2 aftershock. And what's the location of that one real quick? That one also under Lake Almanor. Anyway, it's time to get back to space. But first, check out the links below the video. If you haven't seen the merch shop, maybe you'd like to check out the products there. I'm actually wearing one of them today. It's our Google-defined product. So if you're using the term Google as a verb, you're making my ears bleed. But at least use it correctly, because Google as a verb is correctly defined as to obtain biased search results by using the Google biased search engine. You may not be aware that Google and YouTube are the two largest search engines in the world. Yeah, Google and YouTube. YouTube, which is also powered by Google. So you want to talk about a blankopoly? Yeah, there's a bit of a problem going on with search. And the problem is biased search results. Yeah, junkware became deathware in 2020. Anyway, if you are using Google as a verb, please use it correctly. It means to obtain biased search results using the Google junkware search engine. Let's use it in a sentence. I Googled it, and now I know less about it. So here's a fantastic 24-hour video here featuring 171 plus 131 angstroms. Let's take a look at the most active areas here. So here are the groups in the northeast. They are large and magnetically complex. They are capable of producing large solar flares. More importantly, here is the area in the northwest, as those are even more likely to produce major flares. So as the groups in the northeast get closer to center disk, they're actually less likely to produce large flares. They're more likely to be associated with Earth-directed coronal mass ejections, but less likely to produce large flares. These groups setting in the northwest become more likely to produce large flares as they set, which perhaps tells us something about heliophysics. Moving on to our 10.7 centimeter radial flux, which is currently at 163 solar flux units. 163 is the number of the radial flux. Now, that 10.7 centimeter radial flux does get emitted from the upper chromosphere and lower corona right here in this area, and it is a directly proportional set of data to sunspot number. So the radial flux is just as important as sunspot number, and solar cycle 25 is blowing solar cycle 24 out of the water with sunspot number, radial flux, coronal mass ejections, filaments, and solar flares. Anyway, that's the one-year graph of the radial flux represented by this black line. The red line below it is the sunspot number, and we're seeing a little lull in activity here. Don't expect it to continue. I forecasted a huge uptick in the next month as a result of the coronal hole leaving the North Polar region. Now, as far as NOAA's forecast, they're expecting continued possible geomagnetic storm conditions into tomorrow morning, or at least geomagnetic unrest conditions late tonight. So that's NOAA's forecast. So late tonight, we could see the aurora again tonight. That's my point. Tonight into tomorrow morning, aurora could be visible around the world. Here is NOAA's forecast, although the likelihood of major coronal mass ejection impacts is now waning. So there is the NOAA forecast. That's the Enlil spiral. It looks like a little increase there expected on the 14th also. That looks like a coronal hole high-speed stream, I would suspect. And let's take a look at NASA's forecast. Here we've included the... This is depicting plasma density here. That's depicting plasma density. It is showing things like OSIRIS-REx and Bepi-Colombo and the Parker Solar Probe. No major impacts here forecasted by NOAA either, and not by us either. So it looks like everybody is remaining in concordance about the forecasts. Anyway, moving on, here's the past 4 hours of Earth's magnetic moment from space. Again, we do have a CME impact, a coronal mass ejection, where material blasts out of the solar corona and smashes into Earth's magnetosphere. It's currently going on, but it's pretty mild. So it's fairly geomagnetically calm conditions. That's Earth's magnetic moment from space, modeled by the Space Weather Modeling Framework over the past 4 hours. We'll also show Earth's magnetic moment from the ground, as we do daily on the channel. This will depict the most likely places to see the aurora. Pipeline, railway, and power grid induction. Telluric currents are also likely to be depicted on this imagery. That's changes to Earth's B field, Geospace delta B, the B field being the field that goes through the magnet. We'll let that play through since it refreshed to show the most up-to-date data that we are able. Again, pardon the lateness of this video. We will be blasting through a lot more information. There you can see a little uptick in the past couple of hours there. That's the ongoing coronal mass ejection impact. So far, pretty mild. Current conditions are only a KP of 2.33. And what the heck? Yeah, 2.33 is the current KP index. I thought this usually depicted 3 days or something. Doesn't this usually show 3 days? What's up with that? Anyway, we did see brief periods of mild geomagnetic storm early in the morning yesterday. It looked like we were going to get to geomagnetic unrest early this morning, but all we got to is KP 3.67. So calm conditions here, despite two different CME impacts. The CME impacts were basically as forecasted, just not as strong, and it's impossible to forecast the magnetic fields of those CMEs until they strike a spacecraft. So if there's a spacecraft in between the Earth and Sun, that gives us a little bit of information, but if not, it's very hard to guess. Now we're showing the U.S. and Canada geoelectric field map here because this is a great map to know when aurora are likely to spark up in your location, and it's pretty unlikely. Of course, it's light over most of that map. So, but when you are expecting aurora, this is one of the things that you can use. It's showing the induction into the power grid, which is instantaneously likely happening at the same time that aurora are visible overhead. So just be aware of that. And here's the real-time solar wind data. So here's when this latest CME impact happened. The speed got up to nearly 600 kilometers a second. The density only made it up to about 13.5. Actually, we're seeing the densest portion right here now, just in the past few minutes. 25 protons per cubic centimeter, approximately. About 24 protons per cubic centimeter. Solar wind speed here, 563 kilometers a second, significantly elevated. I would also note on that lower pane that the plasma temperature has dropped. So there could be multiple different regimes happening here, coronal hole high-speed streams and multiple CMEs. It looks like one CME plus a coronal hole high-speed stream to me. The field's not particularly strong here, and the BZ is not strong in the negative or positive. It's all over the place. Another indication that perhaps multiple different solar features are interacting here, or plasma features, I should say, are interacting in between Earth and Sun. Keep in mind the solar wind can't be measured inside Earth's magnetosphere. It's measured out here 1 million miles away at Lagrangian point 1. And there are your GOES magnetometers. A bit of a divergence here. They're both climbing at the moment. That's the GOES 16 and GOES 18 magnetometers. And let's take a look at what's going on in space. Of course, the GOES magnetometers are in space too, but these are ground-based primarily magnetometers. Also magnetometers on stereo A right here and stereo B, providing this top view ecliptic plane field plot. And check it out as forecast. You can see this North Pole coronal hole. Looks like it's starting to move. By the way, that has to vacate the north heliographic pole before we can say we're at solar maximum. So far, still plenty of north solar polarity at the north polar region. Here's our line of sight field plot depicting the north solar polar field in green, south solar polar field in red, and the solar B field in blue. It also shows the gong magnetogram. And let's move to coronal holes. We do have some south pole oriented coronal holes here, finally rotating in the east. Oh, and the sector boundary crossing might be here as early as tomorrow. At the moment, Earth is still in a north pole oriented current sheet. Again, there is the top view ecliptic plane field plot. You can see this sector boundary crossing is coming. Probably by tomorrow. New sunspots could affect that, but I would suspect Earth will be snapping into the South Pole current sheet around when we make tomorrow's video, actually. Anyway, here's our line of sight coronal hole plot, and we've got South Pole oriented coronal holes here rotating in. Let's take a look at those using the SDO Browse Data feature. We'll show yesterday plus today in the optimal wavelength to view coronal holes, 211 angstroms. So again, the coronal holes that we've got here, these are all North Pole oriented. There's a sector boundary crossing somewhere around here. And we've got South Pole oriented coronal holes showing up over there. So just so you are aware of that. And it's time to move to sunspots. Sunspot situation has been mostly stable over the past 24 hours. I don't see any major new sunspots growing or rising. We did get a couple new name groups here, like 3304 there, ahead of 3302 and 3301. Those are the largest sunspots in the northeast. In the northwest, of course, you've got this huge group over here. I'm not even going to try to separate those. And let's take a look at sunspots here. Here is your 1600 and 1700 angstroms 24-hour SDO video. And let's catch a glimpse of those massive setting groups. So you can see those crackling with flares. They are still indeed capable of producing M or even X-class flares. As they get closer and closer to the limb, they become statistically more likely to produce them without even looking at the magnetic field orientations. Here is the northeastern limb. Fantastic close-ups there. As we bring you the most detailed space weather and comprehensive imagery of the closest star that you'll find in the known universe. Moving on to solar energetic particles and solar flares. At the moment, solar energetic particles have calmed down. There you can see the proton flux dipping down to its baseline levels following multiple impacts from relativistic particles. Those polar radial blackouts have ceased. Again, the proton flux has returned back to its baseline. X-ray flux here featuring some activity happening. Once again, as we make the video, a flare is happening right now. And let's take a look at the past 24 hours. There is your 94 angstroms wavelength. Here is 131 angstroms. So it looks like this sunspot down here might actually be gaining some complexity there, as it has been producing some flaring over the past 24, including, it looks like an M-class flare there. Let's get a little closer. Don't be shy. Actually, let's get a little farther. By the way, there's a lot of stuff on YouTube about space weather that couldn't be farther from the truth. We're into facts on the channel. So that's a thing. All right, just hang on a minute here, folks. Take a moment to look up. we encourage you here at the Smash News Network to look up, no matter how provocative that might be. Ooh, looking up at the sky, it's very dangerous. But only if you believe in chemtrails. Anyway, this is what's going on over Lehigh Valley at the moment. You've got Venus, the sun, you got Mercury, Jupiter, Saturn, and the moon all up there overhead at the moment here over Lehigh Valley, Pennsylvania. Want to make your own star chart? Skyandtelescope.org is the one we're currently using. Here's your solar system forecast. As Mercury goes to join the gas giants, Earth remains on the gas giant-free side of the solar system as we're approaching another new moon for May. Here's where things will be on the 19th. We will have a very slender crescent. New moon coming on the 20th. That's where the rest of things will be as well. And let's move on to coronal mass ejections. So here are yesterday's coronagraphs from George Mason. Not the person, the university. Yeah, George Mason U. There may be some minor earthly directed components in there. We'll take a look at some more images and some more coronagraphs like Stereo A and Soho Lasco C3. First, today's coronagraphs from George Mason. There are 31 additional frames. So I don't see any indication of any major CME impacts headed our way. Here is Soho Lasco C2 and C3. And just for some added perspective, let's include Stereo A, which is now located right there, getting very, very close to Earth as Earth is getting close to overtake Stereo B. So there's Stereo A on the left, Stereo B on the right. A great example of a very dense plasma shell there being ejected yesterday. Or actually, it looks like earlier today. Hang on a minute. I'm going to bring that back. There's a very dense plasma cloud there that was just before noon yesterday, actually. See, sometimes these clouds, they don't disperse as you may have expected. You know, as plasma moves away from the sun, it generally is going to become more and more diffuse. And I generally prefer when I do stuff on my computer and have an actual response. That's the way I like things to work. I know it's really asking a lot. All right, so there's that dense core. Great example there of a CME that's very irregular in shape. So this is a prime example of a CME that if this side to the east hit you, it would be a completely different type of impact than if this west side hit you, because as you can see, the east side has this dense core and the west side has like a hollow core. So that is a common thing to see. Coronal mass ejections, they are predictable if you have the data. So let's move to our coronagraphs here before we get to filaments. Here are our custom 24-hour coronagraphs. So now this CME from the southwest, that could have an earthly directed component. Let's see what we can see here from these zooms. If that does have an earthly directed component, it is very minor. It came from this area right down here in the southwestern limb, it looks like. Let's see if we can see that in 193 angstroms. There should be some plasma ejection from right down here. That's another 24-hour SDO video, by the way. So indeed, right from down here, you can see that plasma eject. I'll let it play through one more time for your viewing pleasure. There it goes. And here we go. onto filaments. So we're now at we're at the Cerro Tololo, Chile ground-based solar observatory, and look at the filaments. So, I mean, up here you've got the Jerry Seinfeld and the Larry David and the Bill Burr. Check out these parallel filaments in the south. Wow, there's a lot of filaments on the east side. A lot of filaments indeed. And those are the kind of things that can spark CMEs. This filament here kind of likely to eject as it's right above a massive sunspot. Anyway, if you want to name filaments after living people, make sure you follow us on Twitter. We're all over the internet at Smash-O-Mash, and a brief moment from our affiliate/sponsor. Now, Hemp Lucid has a university where you can learn about the products, so if you're not familiar with what the products are for, check it out. You can find links right below the video to our Hemp Lucid shop. And if you're just on the site, hemplucid.com, make sure you enter the promo code SMASHOMASH to save some dough on your checkout. Yes, save some money on checkout and give us credit, help support the channel by buying your CBDs or perhaps your mushroom gummies or whatever you're looking for at Hemp Lucid via our shop. Thanks to everybody who has. Thanks to Hemp Lucid, the paid affiliate/sponsor. And again, make sure you join us on Twitter. If you are on social media, if you haven't unplugged entirely, we don't blame you if you have, because it's truly, truly pathetic. The censored environment. Just follow the hashtag #NameThatFilament. And name that filament. No, you can't do it in the YouTube comments, and you certainly can't do it in the BitChute comments, although if you're in the BitChute comments, you can tell us that space is fake or whatever, chemtrails are real, space is fake, etc. Make sure you follow us on Instagram for some fitness and lifestyle type posts. Also some dietary stuff showing up there over on Instagram. And here are the past couple of hours. And we're going to cut back to that here. That's the GOES 16 SUVI. First, the last 24 from SDO 171 angstroms, the northeastern limb. And let's don't forget this money shot. That is pretty sweet. And that is the most likely place to see a large flare, including an X-class event. Don't be surprised to see one today. And here's your full disk view in the house favorite wavelength, my personal favorite, 171 angstroms. And that is chiefly for aesthetic reasons, not because of physics reasons or anything like that. Anyway, here is the last couple of hours from the GOES 16 SUVI, and as you can see, that latest flare is indeed coming right there from the northwestern limb. Probably no surprise to our regular viewers. And let's move to bonus features, because there's lots more stuff to blast through here. So Satellite's community dashboard here showing some minor surface charging hazards over the Central Pacific Ocean. GOES electron flux here in an operating range. It's looking nominal. It's about where the forecast was by NOAA. And here is the forecast model. Expecting just moderate levels of electron flux for the coming days. No surprises there, perhaps. Here is the one-year graph of the greater than 2 mega electron volt electron fluence, which is the same data that we just showed in multiple different forms. It is measured at the F layer of the ionosphere. That is in many ways the bridge between Earth and space. Let's show the vibrational frequency of that layer of the upper thermosphere. So here it is in raw megahertz. That is millions of vibrations per second. Keep in mind it's very diffuse in space. 300 kilometers of altitude is high enough for most people to agree that it is in space. I think everybody would agree 300 kilometers of altitude would be space. And anyway, that is the ionogram. Here is the anomalygram depicting anomaly in megahertz from a 30-day median. If you're looking at this area right here, that's the South Atlantic anomaly, Earth's weakest point in its magnetic field. Also up here at the western equatorial African coast is a second slightly less anomalous anomaly. It used to be called the South African anomaly. You could call it the equatorial African anomaly, I guess. But those are the two weak points in Earth's magnetic field. And if you think it's turning into a quadrupole or an octopole field, see the earlier portion of our video, as that's just not the case. One of the many indications that it is incredibly unlikely, infinitesimally likely, that Earth's magnetic fields will reverse. Anyway, here's the latest image. That's 1345 Universal Time ionogram and 1345 Universal Time anomalygram. Will also show the total electron content. That's the free electrons up to about 12,500 miles of altitude. Those free electrons can cause signal refraction in the form of GPS errors. And we do have electrons quite a bit out of place here, so you may be seeing some major GPS errors. Try turning on your Wi-Fi location accuracy if you're expecting your GPS to not be navigating well, or if it's obvious from looking at the output. But yeah, we've got some electrons out of place here at the moment, despite fairly nominal levels of electron flux. That's the total electron content on a global basis. We'll also show the North American total electron content anomaly from the 10-day average. It's going to depict high electron counts in red and low electron counts in blue. And we will close out the space weather section of this video with the latest intensity-gram. And don't forget the latest magnetogram. Again, these sunspots have been mostly stable for the past 24, so here's a full disk rock back. No major changes that I'm aware of. If I've missed something, let us know in the comments. We endeavor to be thorough, and let's take a look at the planet's temperature. So, this is the hottest place in the world right now, near India. It's over 114 degrees Fahrenheit. Pretty sure that's the hottest spot. I mean, Saudi Arabia's got some hot ones. We've got some hot areas in Africa also, but not to 114 degrees that I'm aware of. Quite warm, and it's only spring there. Let's check the coldest parts of the planet. Not surprisingly, on the highest, driest continent. How about negative 89.5 degrees? How about negative 92.6 degrees near the South Geographic Pole? Actually, that's like 1,000 miles off the South Geographic Pole, but anyway, that is what is going on in terms of Earth's temperatures. Hopefully that didn't frighten you or create any cognitive dissonance. I literally just showed the data. Let's take a look at the wind patterns for the eastern world. Significant cyclone here in the Bay of Bengal, by the way. Let's take a brief look and see if we can find a wind speed here. So probably well over hurricane speeds there. We are showing, I did see 66 miles an hour. I suspect it's quite a bit stronger than that. Become a gold or silver Smash Team member, by the way, and you'll get reports about that, detailed reports on the daily. All right, anyway, those are the surface winds of the eastern world. Here are the jets. The 250 hectopascal winds, which depict the jet streams over the U.S. and South America and Central America. Looking like this. Some cold air being injected into the northwestern U.S. once again from western Canada. Also a strong low here over the north-central U.S. Here is the surface wind scenario. And surface winds of the central world. And here are the jet streams of Europe, Africa, and the Middle East. Next, clouds and fog over the Americas. As we zoom in closer and closer to the lower 48. Great equatorial cloud band visible there. You can see that fantastic equatorial cloud band as the jet streams don't regularly cross the equator, funneling clouds to that area. And here is the weather.gov map. So huge amounts of flooding here in the forecast. We'll show the total accumulated precipitation first. There's the key, weather.gov. If your location is lit, click your location. We've got bad air quality for the southeastern Pennsylvania. That does include my location. Bad air quality alerts there in the mid-Atlantic. So here's your temperature anomaly forecast, and extremely high temperatures showing up for the Pacific Northwest. You're looking at 16 plus degrees Celsius above normal there. That's your temperature anomaly forecast for the next 72 hours based on the GFS model. And how about the total accumulated precipitation model? There it is, total accumulated precipitation. And the forecast is still for over a foot of rain for that portion of southern Texas. 72-hour GFS total accumulated precipitation model is what that's showing. That is rain in inches. And we'll also show the pressure and precipitation forecast here. Repeated bouts of strong storms there for southern Texas. So southern Texas, you're going to get hit, then you're going to get hit again, then you're going to get hit again, it looks like. That's your 72-hour GFS forecast, pressure and precipitation. Some serious storms coming there to Texas. Here's your lightning mapper. This is the past about 12 hours, 10 hours, something like that. Here's a real-time lightning map from lightningmaps.org. And we do indeed have quite a few terrestrial strikes here at the moment. Hey, Memphis. You got serious thunderclouds to your south. Nice. There could be some training there. We'll show you the Doppler here momentarily. I suspect Knoxville is in the crosshairs. Anyway, that's your lightning map here. Quite a bit of lightning here around planet Earth. Continuing on to invite you to join us over at smashomash.com/smashteam. Yeah, the official subscription services site of this channel. We launched it back in October 2021 because we needed more capabilities than Patreon. Not because there's anything wrong with Patreon. We are actually still there if you want to donate that way. If it's more convenient, feel free. Smashomash.com/smashteam is where the extra content is. Thanks to our silver and gold Smash Team members, especially, the best value is the gold annual paid-up subscription. These videos were brought to you in part by the contributions of the Smash Team and at massive personal risk and expense by Smash staff and I. We've also opened an Amazon shop. If you want to see about my chrome radiation reflective hat, you can find that there. Also, kitchen gadgets, office furniture, including bunker tubs, bulk spices like the cocoa that I drank just this morning to increase my nitric oxide levels. Yeah, nitric oxide levels. People pay a lot of money for that when they could just have some cocoa, and that would work out great for them. But hey, what can I say? Welcome to space. Welcome to the Neo-Renaissance. Congratulations on realizing the channel exists. If you're unable or unwilling to open your cobweb-encrusted wallet, help us out with clicks. Hit us up on social media. Press share. Press comment. Press the like button, etc. We'll wait for you to press the like button. Have you pressed it yet? Just press the like button, no big deal. Then we'll start the video. Just kidding. Here is our satellite map. And give that a minute to initialize. It's more than worth it. The great satellite imagery there from windy.com. If you haven't seen their mobile app, perhaps check it out. You can see that very strong low there just to the east of the Colorado-Nebraska border. Looks almost like an inland hurricane, as there is a lot of interaction happening there, which we'll show you here in a minute. First, the U.S. Doppler radar. Hey there. Come join us, National Weather Service radar. You're invited. Oh, man. Jeez. Just give it a minute to load, folks. I assure you that our internet connection is shockingly fast. We've got Verizon Fios, which is pretty much the fastest internet you can get without a T1 line or something like that. All right, so here is the U.S. Doppler radar map. All 50 states of AUSA, the allegedly United States of America. There is the lower 48 view. Here is clouds and fog. You can see that counterclockwise rotation there, moving north through western Nebraska. Last but not least, there's the water vapor map. And that low is not super strong because it doesn't have a lot of moisture in it. It is still a very low pressure system, but it is surrounded by dry mass of air, which does not help to strengthen it or create convection. Remember, dry air has a tendency to tamp down weather systems. When you see that surrounding an actual hurricane, you can expect the hurricane to weaken. Anyway, here's your recap. U.S. Doppler radar. Is the snow falling around the Great Lakes? I think some of that was actually snow there. Here is clouds and fog. And there is the water vapor map. And that is where we'll have to end this thing to get it onto your screens ASAP. So thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-A-Mash. Look for some possible aurora videos coming out today. I think we caught some imagery that we may upload. In the meantime, may that solar wind be at your back and that nonsense absent from your YouTube feed.